Hey guys, I'm trying to attempt this problem. Let's see if I can solve it. So it says that the pump shown in the figure 5.6 produces a steady flow of 10 gallons per second through the nozzle. Determine the nozzle exit diameter d2 if the exit velocity is to be 100 foot per second. So let's try it out. So first thing, the diagram, if we look at carefully, there's the flow. The flow starts in here, and then it goes through the pump, and then here, and the pump, the flow is actually accelerated. So the pump is actually gets the water from here. It actually accelerates the water in this lane. So and then the water gets pressurized here due to the diameter being smaller, and then you can see that the cross section here is larger, that's coming out through the pump. So what we are looking for is from section 1 to section 2. So it will be at we already know the velocity at 2, and we don't know the diameter. That's what we are looking for, but we know the steady flow of 10 gallon through the nozzle, gallon per second. So we already know the the steady flow of it goes through the nozzle. This is the nozzle. uh, so to tackle this problem, first we already know our V2. We already know V2, which is 100 foot per second. And we already know our D2. How to solve it? This is easy. We can use Bernoulli's equation. And then we know that also, more than that, we have 10 gallon per second that's been getting out of the nozzle. Okay, so what's Bernoulli's principle? I don't remember it, so just go and check it out. Bernoulli's principle. So these are the equations that they give us. This is the mass flow rate that we have, and we already know the velocity. Sorry, my notebook fell off. We already know the velocity, so this is supposed to be m dot. I didn't know how to. This is m dot. That's mass flow rate. And to solve that, we already know that m dot is equal to rho q, which is rho times the cross-sectional diameter, pi over 4 d squared times the velocity. So we already know the mass flow rate. We're just looking for d2. To get d2, I will just keep it as d2 like that. We will divide mass flow rate by pi over 4 rho v, and then we already know this is 10 gallon per second, and this is pi over 4 I don't remember the density of water, and then the velocity, which is 100 foot per second, and this should give us the diameter of the nozzle. So this should be the answer. Thank you.